I figured that was a welcome sound. All right, so are we ready?
Yeah.
All right, cool. It's 1984, the year of peak computing, and if you're in a different session than that, then I'm in the wrong room. I'm Charles Mangin. This is my second year at MacAdmins on Slack and elsewhere. You can call me Option 8 or the Mac Nerd. Sometimes I pretend to be 3 bash scripts in a trench coat. And just for a little flavor, according to my last performance review, I am an arrogant know-it-all that management finds difficult to work with, which is particularly harsh because that was my self-evaluation. Fair warning before we get into things too much, I do talk fast sometimes, especially when I start on a roll or go off on a tangent. So if you can't catch something, you're welcome to interrupt, but I may just ignore you. I also talk with my hands a lot, so you guys in the front row, you may want to wear eye protection. And so, let's dive in. It's 1984. Oceania is at war with East Asia. Oceania has always been at war with East Asia. It is simultaneously 1 year until and 29 years since, or 1 year since and 29 years until Marty McFly became or will have become the first human to travel in time in a modified DeLorean DMC-12. High school rebel Ren McCormick taught the small town of Beaumont, Oklahoma, how to dance and to love again, maybe. 4 unlikely heroes in coveralls defeated the demigod Keymaster Vince Clortho, Zool the Gatekeeper, and Gozer the Gozerian, aka Gozer the Destructor, Gozer the Traveler, Volgus Zildrahar, Lord of the Cebuia, using unlicensed portable particle accelerators. And, last but not least, an obscure California fruit company took the world by storm with a Super Bowl commercial that was aired only once, but somehow everyone alive claims to have seen it at the time. As it turns out, they make computers too. And as you all know, I'm sure, 1984 saw the release of a new machine from Apple Computer with a 9-inch monochrome screen, 128K of built-in memory, 32K of ROM, that's kilobytes, y'all, the K, a built-in floppy drive, dual high-speed serial ports, support for this newfangled mouse gadget, which is, of course, only the latest and greatest in human interface devices. A brand new CMOS 65CO2 processor running at 1.023 megahertz with an M, and all of this in a compact form factor with an integrated carrying handle. And I don't mean this guy, of course. I'm talking about this. The Apple IIc.
Yes.
What's that?
I love that system.
Yes. This is compact portable from 1984. On board has everything that you need except for the display. Apple had a couple of options for the display. One of them was pretty lousy. But so that was the Apple IIc. There was, of course, also the Macintosh. So no doubt the first Mac and its ilk were a bit of a paradigm shift, considering they introduced a great many aspects of the personal computer that we are all aware of and familiar with now, still 40 years on. It wasn't the first machine with some of these features, but it did bring out things like, things that were previously only available in an academic situation or an enterprise, something that was on a much more expensive and much more exclusive environment, and brought them to the desktops of the rest of us. Things like a mouse-driven graphical user interface, a GUI, hierarchical filing, a desktop metaphor, what you see is what you get, a WYSIWYG. It eschewed this command line for friendly point-and-click interactions using icons. But you already know all this because this is the MacAdmins conference, not 1984 after all. But I'm not here to talk about the Macintosh. Cute little thing, but underpowered, underwhelming, and a step backward, as of 1984 at least, at first. Considered the first color-capable Mac with expansion slots. The Mac II wasn't going to be here until 1987, so that's 3 years away, unless you have a DeLorean. No, the apex predator of personal computing at the time was already quietly lurking, sitting on millions of desks, kitchen countertops, and dining room tables. Because, of course, at the time, people hadn't quite figured out what furniture was going to be appropriate for this computing revolution. And I do mean quietly because, unless you added one yourself, no fans. Quiet. And it was such a success that it propped up Apple financially for the better part of the next decade, while the Mac found its footing, and then lost it again in the mid-90s. I won't get ahead of myself. The apex predator, that peak personal computer, of course, talking about the Apple II. This is a 2E, a specimen from 1983, and I've got one up here that's in an aftermarket clear case if you want to come take a look and see what very little it contains as far as hardware, chips and boards and whatnot. Almost everything that's in it, aside from the main board and the power supply, is an aftermarket add-on. Some of them are from the 80s, and some of them are much more recent, from the last decade. So still things being made for that machine. Of course, the 2C, which was introduced in 1984, has all the stuff that's in the 2E, minus the slots, but it does have the Hartmut Esslinger frog design, industrial design, mouse support built in, so no add-on cards, and a sweet carrying handle. And then when the Mac first arrived, it was competing, of course, with Apple's established platform, one that had already been established in the market for 7 years and would continue for the next 11 in one form or another, and finally discontinue the last Apple II line in 1995. At that point, it was an Apple II on a card that would go into an LC or a Color Classic, something like that. And you could run Apple II software from floppies with an attached floppy disk. So why am I talking about this? The Apple II, what were its advantages in 1984 over the Mac and this shiny new graphical user interface that Steve Jobs is all on about? It came on instantly. It didn't have to load extensions and things from a drive. By the time the beep faded, the machine was ready to take commands. All the necessary functions, BASIC was in ROM. You could just fire it up and get started without having to wait for anything to load from a disk. Obviously, you could boot up from any number of different kinds of floppy disks or eventually hard disks as well. It had expansion slots. So right away, anybody that could open the case, which didn't require any tools, you could upgrade the memory, a bunch of other capabilities. So there were hundreds of different hardware accessories and just as many hardware manufacturers, third-party manufacturers. They had sound cards, video cards, serial connections, network connectors, even things like coprocessors and accelerators would take it past the 1 megahertz. So you could get as much as maybe 4 before it smoked out. But there were also thousands of third-party software titles, games, educational, business titles, home office, all kinds of stuff, everything that you would need to start a business, run a business, run one into the ground, bankrupt it, et cetera. And it was well-established ecosystem of Apple II software that partly kept it going for 11 years because educators and a number of businesses that had custom software didn't want to replace their hardware because it still worked just as well as it ever did. And this new little tiny 9-inch black and white screen had nothing that their Apple II that could connect to anything with a NTSC signal would be happy to run. Development on the Apple II was super easy. No need for a separate workstation. Like when the Mac came out, you had to have a Lisa and a special cable to connect the two to build your software and run it. You could only use it, Apple's Pascal development tools. It was very closed down, which, again, first generation, very Apple. That's been their playbook for decades. But it was kind of frustrating at the time because people wanted to make apps for it, but it was so much easier to develop for the Apple II and the other 8-bits that were still there. Your TRS, Atari, Commodores, that kind of thing. And anyone that was interested in becoming a software author could really literally pick up and learn the onboard operating system, the basic that's in ROM. It had a built-in monitor and disassembler for 6502. Apple and third parties sold versions of Pascal, Fortran, Forth, Logo, C, and the list is, there's a list as long as your arm of obsolete or dead programming languages that are probably still running in some form on an IBM mainframe in a bank somewhere, patched most recently in 1999 so that they would survive 2000. But there were even multiple operating systems you could get for that same hardware. Not all of them were actually Apple's operating system. You could get Apple's DOS and then ProDOS, and then there were things like Diversity-DOS, David's DOS, a variety of things that started with D. You could even get CP/M from Microsoft with an add-in card that would run CP/M on a Z80 or Z80 processor, a coprocessor. There were even graphical interfaces, operating systems like GEOS, which was pretty impressive on an 8-bit machine, but it could be displayed on any NTSC TV or PAL, the not North America part of the world, on any big screen projector, tiny little security monitor, or whatever you wanted, anything in between, and in color. 16 glorious hues, and that include 2 grays. Most of the time they look the same, but there were 2 different grays. And the whole thing is running on mostly off-the-shelf, non-proprietary hardware. And the folks that came up and looked at this one earlier, they could tell you there's really only a handful of chips on here. And there's only a couple on there that are stamped with Apple logos, and all the rest are essentially logic chips you could have gotten at Radio Shack. And many of them actually were. So the hobbyist influence, the legacy of the Homebrew Computer Club, still pretty clearly there, considering how easy it is to create new hardware for it even now. It includes things like, I've got in here an HDMI card. I've got a card that reads USB, compact flash. There are SD card readers, all kinds of connectors for Wi-Fi, Bluetooth, accelerators, coprocessors, all of that. And it's possible because this is such a, well, it's a really well-documented, but also very open design. And it's still chugging out new, people are putting out new releases for, like this case, for instance, even 40 years later. So, so what? What is still relevant that's left to learn from a 40-year-old computer? Ageist much? Pfft. In other words, where's the point, Charles? Why should anyone be interested in an obsolete 8-bit computer that runs at a single megahertz, 1.023? And I'll tell you why. It's a gateway drug. Even now, it is a gateway drug to anyone who wants to pick up a soldering iron or type on the very clicky, delightfully clicky keyboard. How many of the people in this room have a degree in computer science or some kind of IT-related field? It's actually more than I expected. How many of those that raised their hands graduated more than, say, 15 years ago? Okay. Back when dinosaurs roamed the internet. And for everybody else that doesn't have a CS degree, do you feel like that has hindered your career at all as a Mac admin? Raise your hand if you feel like, oh, I should have gotten a CS degree instead of, whatever, like I got a degree in graphic design. Don't regret it. Anybody? Really want to go back in time and get that CS degree? That's what I thought. So, I have a bachelor's degree in graphic design. That's where I first used a Mac at design school. Eventually, I made my way around to being the guy that fixed them and maintained them, and then eventually managing large groups of them. And I never had any foundation in things like programming or binary math, or algorithms, other things that any first-year CS major would probably cover, or things like von Neumann CPU architecture, spoilers, or how memory and processors work, any kind of electrical engineering. And I don't think it held me back. Even when I was making a living in part as a web developer, I still wasn't building applications. Nothing was compiled. I wasn't worried about memory management or garbage collection, which probably is why I was not very good at it. But I was just doing mainly layout, things like HTML, CSS, JavaScript. And that appealed to me partly because I've always loved to tinker with anything that's mechanical, electrical, but I really don't have any desire to be a serious programmer or engineer. And by serious, I mean something that someone else could use, make something that someone else could use, seriously without it breaking. So, for instance, back in the days of doing repairs on CRT monitors, I learned about things like discharging the flyback transformer before the stored voltage in the capacitors had a chance to stop your heart, which is good practical advice and probably the reason I still have all 10 of my fingers. But I really didn't have any idea what most of those terms really meant. I knew don't touch this thing bad. Or more appropriately, things like what a buffer overflow is, or how virtual memory really worked, or what a lot of the terms and checkboxes really meant when I was using them literally every day, reading error messages, documentation, and troubleshooting, configuring Macs, things like that. It's like, I know that this is the thing that turns on that, and that lets you do the thing in Adobe that you couldn't do without that box checked. But I was always curious. And in my sort of early days of my career, I first tried my hand at automating things with AppleScript, and it felt sort of eerily familiar. Not the language per se, because it is a little bit of an awkward programming language, even in its later iterations, but more the concept of scripting. Mapping out sort of the logic, the choices that I had to make, writing out the steps in a particular order, telling the computer what I wanted it to do. Nothing super complicated. I mean, it's really just basic programming. It's just basic programming. It's an interpreted language. I know this. So I did this when I was a kid, right? And I still played around with those same computers for a fun diversion. They were retro now. This was early 2000s or whatever. But 10 print, hello world, whatever. And that was 20 years ago. And my little niche hobby, collecting and tinkering with, even then, they were ancient computers and really didn't have much to offer the modern world. That kind of took on a new dimension. And since then, I figured out that if there was something new, some technology, some subject that I struggled to understand in the modern world, or if I just want to explore something without having to, get all the prerequisite CS master's degree items first. Well, let's see if I can make it happen in 8 bits, 1 megahertz. But again, Charles, so what? What can you do with it? Admittedly, most people into retro computing will go in for nostalgia, obviously reliving their youth in the 80s and playing games mostly. That's a perfectly valid reason to get, put together a MAME cabinet, or get the old computer that you had when you were little and get some ROMs and an emulator or two and fire it up. But a lot of people also like the old hardware for things like distraction-free writing. There's no internet connection, no Facebook, no pop-ups, no alerts, not even a real-time clock to tell you what time it is to tell you to stop writing. Or for running like a single-purpose application, it doesn't have any frills. There are TRS-80 type machines and Commodore type machines that are running the label printers in workshops and CNC machines and things that have been running perfectly well for 20-odd years, and they only really break down when the machine breaks down, not when there's nothing wrong with the computer, except maybe the floppy disk needs to be replaced with something that is not a floppy disk. Obviously, there's the hipster contingent, but more seriously, there is a new sort of movement in digital preservation, preserving the artifacts of the pre-internet age, the online cultures of BBSs and dial-up systems, that sort of thing. Plenty of recent media, images, apps, music, whole community digests born digital are disappearing. When those hard drives fail, or those floppy disks flake off into dust, they're gone. There's no trace that they were ever there to begin with. There's no, there's no Stonehenge to look to, no archaeology that can be done. So things like that belong in a museum or a library. So this is PSA number 1, archive.org, a highly important, essentially publicly funded, but crowdfunded for the most part, organization doing highly important work with regards to the disappearing digital world, among other things. So I would encourage you to donate time or money to archive.org, #notsponsored. So no, really. It's 2024. What is an 8-bit computer good for in 2024? So I said, gateway drug. What I really mean is learning tool. And so this is my main thesis. If you haven't been paying attention so far, you've just been laughing at my jokes because everyone else was, that's fine. This is where you start paying attention, 20 minutes in. You can be a better programmer, script writer, automator, whatever, by learning to code in what is essentially the equivalent of ancient cuneiform, which is assembly language on an 8-bit machine. And honestly, I found learning assembly as an adult, which was, like learning a language as an adult is always harder than when you're a kid, right? Assembly is so much easier than bash. Oh, sorry. There we go. So this is the entire 6502 instruction set. 56 commands, and that's it. Every instruction is there. Sorry. So if you need to do something that's not there, well, you'll have to make it up from those pieces, like Lego. All the components are there for making loops, conditional branches, if this, do this, so branching logic, variables, kind of, reading and controlling inputs and outputs to the hardware. It's even possible to do things like self-modifying code. And it really is very easy to pick up, partly because you work within really very limited resources, within the bounds of no value greater than 8 bits. So it's 0 to 255, and that's it. 2 hex, 2 characters in hex. And you're forced to optimize your code either for speed or to fit in the space of the memory, in which case is 64K, 16 to 32 of which are already occupied by ROM. And you can optimize for one or the other, but usually not both. The advantage, of course, working within those constraints is that you own the machine. There's nothing there, there's nothing happening that you didn't put there. You're not waiting for the processor to cycle because it's working on some background task. It's not waiting for an internet connection or a URL to download or DNS lookups. If it's happening, it's because you put it there. And so as a bonus, you get to debug your work literally at the level of looking at the individual processor registers. So when I do a thing, this logical flow affects these bits, and I can watch them in my emulator one step at a time. This doesn't, why does that not turn to 0? It's a 1, and it stays a 1 all the way through all of these instructions. So now I know that, for instance, and if diving into assembly feels a little too hardcore, there's always BASIC. And BASIC is honestly a lot like learning shell scripting. You're dealing with variables, you're putting things in a, like I was saying before, into that step-by-step order. And it has similar constraints as far as what it can do, what you can't do, things like that. It's an exercise in sort of working again within those limited bounds. If you don't follow the sort of the best practices that are the same in Bash as they would be in BASIC, you end up with spaghetti code that goes all over the place. And it's not good spaghetti. Some other kind of pasta that's messy, difficult. And just as a hobby, picking up an old magazine or digging through the archives of something like on archive.org of like hardcore computist or whatever, there are things that they did in the 80s as optimizations for speed or tips and tricks to do something in 3 instructions instead of 10. And those optimizations, those tricks, a lot of them are still valuable today as a way of making your modern code run faster. I know that I don't need this value until later, but I'm going to set it up here because if I set it down there, it means I have to pause what I'm doing here. I mean, a bad example, but you know, there's lots and lots of stuff from the last 40 years, most of it, you know, in the 80s and early 90s, in BASIC and assembly that is ripe for picking over for your own projects. Sort of like the back catalog of Marvel Comics. They're continuing to pull stuff from the 60s and 70s, and they've got 60 years worth to get their stuff modern. All right, so this is where the sound kicks in, so I'm just going to make sure that it does. So within the constraints of the 8-bit, these are some of the things, some of the topics that I was able to explore and get a better understanding of in the 2020s from a computer from the 80s. So this is, I don't know if it's in stereo or not, 2 Apple IIs, which have a 1-bit speaker. It can either go click or not click. And they are coordinated, playing a duet. So things like music theory, how do you do sound generation, data transfer, error corrections, doing MIDI between multiple endpoints. And let's see if it'll go. Oh, okay. No, okay. I'll need to change my screen mirroring. Screen mirroring to mirror. There we go. Okay. So one of the other things that I started getting into with Apple II stuff is exploring data structures. And you look at an array of cells in, come on, no, caps lock? Yeah, whatever. And so I recreated Minesweeper as an exercise in working out how the game mechanics worked, but also, like I said, data structures. How does the array of arrays essentially work? And how do you calculate where something is in that array if you don't know where it is, that sort of thing. I also love playing coin-op video games, so I rebuilt a very, very simple version of Centipede. I call it Octopede. And it actually uses a joystick and everything. But recreating the movement of the centipede and the spider and finding the rules that it has to follow as part of the game. This is an original game I created called Drop Blocks for obvious reasons. And this should be the computer playing against itself. There we go. Okay. It's a head-to-head 2-player game, but I just set it to 0 players. And so again, working out things like how do I find things in a data, in a large data structure? How do I find it if they're matching? But also game mechanics, and user interface theory, things like that. Let's see here. Let's pause that. And then animation, taking a bunch of still frames, processing them. I learned a lot of Python doing this. And this is taking that, is it Ed Weird, Muybridge thing, processing it down to, in this case, 4 colors, so the 4 blues, and then it looks different on the different color palettes of different machines, so I managed to get it to process, but then also figured out how to do, basically do it in text mode. So taking all the values of gray. I don't know if you got something here.
Oh, no, I was just saying, I remember doing this kind of stuff on my Apple II.
Yeah.
Growing up, like making weird shapes and things just in text.
So this is again, translated into basically strings by Python and then piped through a processor that's running on, in this case, an emulated Apple II. And I can pause it. And then, like the rest of the world, kind of got fascinated with cryptocurrency. And so how do I understand building a hash, running a process that hashes a thing with a nonce, and what's SHA-2, SHA-256? I don't know, but I can break it down into steps, and I can do the math, do all the bit manipulation, because that's really all the SHA code is doing, is bit manipulation. It's shifting things left and right. I know how to do that. It's just to rotate left or a shift to the right, do the hokey pokey. But this is actually working on, well, it's a really old block at this point, but it's working on a Bitcoin block. And every time the coin flips, it's found something that's a reasonably good candidate. They're never good candidates. But I did the calculations again, and on average, at this speed, 1 megahertz, it's doing 3-ish hashes per second. That's hashes, not mega hashes, giga hashes, whatever. And so the result is in an average of 37 billion years, heat death of the universe. This will have mined 1 Bitcoin. But it's legit. It's actually doing the hashes. It's doing all of the necessary pieces for building the nonce and the hashing the hashes and so on. So it's that's how I got to a better understanding of cryptocurrency, but also hashing, encryption, that sort of bit manipulation, checksums like MD5 and things like that. How do we know that there's no collisions? And really, we don't. It's really just us up to trusting the NSA. But that also got me into thinking, eventually, about other sorts of algorithms. This is a fun algorithm. It's taking the, in this case, the URL for that dueling banjos, and turning it into a QR code. How delightful. That is some effed up math. Because if you look, okay, so that's just a bunch of black and white squares, really. But there's, yeah.
Did you do that with pixel graphics?
Mm-hmm.
Did you do that with pixel graphics, or are those the kind of graphical characters some microcomputers had where it's just chunks of pixel in a character piece of
Oh,
character?
on the Apple II, it didn't have that until, well, it had like mouse text much later, but this is a graphical mode called low res,
Okay.
obvious
40 by
reasons.
40.
This is single low res, maybe it's double low res, I don't remember. This is double low res because it's more than 40 columns wide. And it's basically black square, white square, but nothing in between. I could do it in 16 colors, but I did it with these two. But the way QR codes work is fascinating if you ever decide to get into it and are having trouble sleeping one night. You can obscure as much as half of that and have it on like a 40-degree angle. And the processing that goes into it to create that is robust enough that an app on your phone or on your computer or whatever can convert it back to the bits that it originally was. So data compression and error correction and just processing of data. There's a lot that goes into making a QR code. And I only figured that out by trying to recreate it. This is my experiment in emulation. This is an emulated Apple II, which is a 6502, running at 1 megahertz, emulating an Intel 8080, which in real life would run at 4 megahertz. This is about 0.3. And that's the processor that's inside the Altera 8800. And so I've got it running a program that blinks the lights. So it's taking a 6502 instruction set, converting it into an Intel instruction set, running the Intel instructions, and the result is which bits are on and which bits are off are blinking the lights on the screen. It's all fully interactive, so I can, let's see, I should be able to step it. If I can get it may just be that it's not in caps lock mode because a lot of these things require caps lock. There we go. So I should be able to step through, I can step through the code. I can debug the Intel instruction set in a 6502 emulated on an ARM Mac that's probably emulating it in Intel with Rosetta. And it's just emulators, it's turtles all the way down. Which is actually the title of a paper that I wrote for POC or GTFO. If you're familiar with that, look it up. And if you're not, then also look it up. And if you're familiar with war games, this is Whopper. This is a very simplified neural net playing against itself, trying to figure out the best way to win at tic-tac-toe. And that's what it's doing. It's learning how to do that. Every time it wins one side or the other, if the X side wins, then that neural net goes on to make 2 more. And then it plays against itself 256 more times. And it doesn't stop until it ties itself 256 times in a row. At which point, it can't get any better because it doesn't have anybody better to play against. And you would be amazed the number of viewers I got on Twitch when I just turned this on Twitch and let it run. Days and days and days. This one is one of my more recent. This is a very small language model, sort of a SSLM. And it's got the first half of Shakespeare as its corpus. And it is, basically it's looking at 16 characters at a time of text and predicting the next character. So the 17th character, wherefore art thou dead? Well, wherefore art thou? Sure. Art thou dead? Hey, that's a, it makes some convoluted, messed up, but Elizabethan text. Doing it character by character is uber slow. But tell you, doing it with full words and sentences, with all of Emily Dickinson's poems, and this is doing the same thing that a very low level, very simple LLM, ChatGPT 0.1 or whatever would do. Because it's, again, it has a very small corpus. It's like what I can fit on, in this case, it was probably like 1 or 2 megabytes of a drive image. And that's it. All the rest of it's happening in memory. It's saying, what's the next word? What's the next most likely word? And it's all, again, about building those data structures, doing the statistical analysis, and then following the bouncing ball. And yeah, that's that. So that's the demo. I appreciate. Yeah, there we go. Now, if I can get my cursor. Nope. Oh, all right. Okay, stop. There we go. Go back to the separate display. And then I can go back to Keynote. Promise I practiced this before. There we go. All right, so how does this work? How am I even how am I applying all this weird mumbo jumbo that I'm doing on the 8 bits with connecting that with 2024? How is that even like relevant, or how am I making that connection? If you'll excuse me. Oh, yeah, right. Most of the ways that are important, even an Apple II, this one from 1983, still a modern computer. It's just that it's simple enough that a person can understand the whole thing all at once, and everything that it's doing. I'm not saying that I understand everything that it's doing. I don't understand the whole thing, but there are people that do. Smart people. I know, sick burn, right? But those people that are smarter than me, that can grasp the operations of the whole system at once, every aspect of it, fully documented, and not just because it's been around for 40 years, but they documented it back in the day. Like, it was that way when it was new. Woz, the hairy one, he marked up the circuit schematics for the Apple II himself and commented the code listings in the ROMs and gave it all away with every machine that they sold. At least the early models. Later ones, they were a little bit more protective of. But that's the whole computer in drawing form. And if you can read those, good luck, it's very pixelated. But if you could read those, you could rebuild it today, again, with mostly off-the-shelf Radio Shack parts. And then this is the ROM. They gave this, well, they probably sold the book, but you could get the book with the ROM code listings for what was in the ROMs, which is kind of amusing now, since distributing those ROMs, those same ones now, 40 years later, it'll still get you a cease and desist order from Apple Legal if you flaunt that online, so I've heard. But so every byte of that memory, every resistor and every chip on the PCB fits in a single book. Okay, so 2 books, really, if you want everything. Well, okay, 3. These 3 books and this lamp, but really a lot of it is duplicated. But how does this remotely relate to a shiny new M3 ultra mega spanking fast 64-bit ARM? The modern Mac, which Apple presents in this very shiny, abstract, simple block diagram way. Well, there's your memory and your CPU cores, and then the ponies and the rainbows. And then there's the bubble gum and the duct tape that are holding it together. And then that's sort of a simplified diagram of the arithmetic logic units. And that's a really simplified diagram of the fetch and store parts of the, okay, so that's efficiency cores. Okay, my point is, all of that is based on von Neumann architecture, spoilers, something I picked up as I was doing my self-directed studies in Computer Science 101. Modern CPUs and even like a 50-cent microcontroller are massively complex by comparison with the 6502 or the other 8-bit CPUs from the 80s. But they're all built on the von Neumann blueprint. All the extra pieces, all the extra complexity, all the trade-offs, speed for power and heat, they're all just accommodations for making that go fast and for overcoming the von Neumann bottleneck. Again, a term, I guess it's Computer Science 101, I don't know. But that really means that the same resource, which is memory, is responsible for representing both data and instructions, which means the CPU is constantly either waiting for data for its instructions to process or for instructions on what to do with the data it just got. But it all boils down to bits. It's all just bits. So it's like a 1,000 horsepower race car engine and a Model T engine are both internal combustion engines. They're both engines tied to 4 wheels. All the extra power and speed and extra complexity, it's all solving the same problem, and that's converting potential chemical energy into horsepower at the wheels. It's all this. This is the von Neumann fuel, air, and spark. And then traction and gearing and gear ratios and steering and all that. But you get the idea. So understanding the fundamentals, the core principles, whether it's computing or internal combustion engines, it's important to expanding your knowledge in pretty much any field. If you can figure out how to make that broken Model T work again, it'll make you a better race car mechanic, or at least more marketable as a Model T mechanic. I don't know. I don't know what the market is for Model Ts these days. But tinkering like that and hobby pursuits like these are a learning tool for what you might do in your everyday job, right? And is that what I'm giving my talk about here in 2024? Let me get this straight. You get a better understanding of modern computers by learning about old computers. And all computers are really the same underneath all the added complexity. So understand computers. Thank you for coming to my TED Talk. Duh. But here's the thing. I said before that not having a CS degree didn't keep me from being a good Mac admin, and I still stand by that. The reason that I'm good at my job, annual performance reviews aside, is that I interact with the people as much as I do the machines. And learning how all the bits and bytes fit together, that's definitely made me better at understanding the machines and what they're doing. But the job, well, it's made of people. You're all people, right? So making presentations like this one, public speaking at all, something that I can only comfortably do now, in part because I had some fun projects that I was doing on the Apple II, and I wanted to share them with the hobbyist community. Online, web forums, taking pictures, doing videos, things like that, places like Hackaday, and then eventually in person at an annual conference that happens every year, still in 2024, called Kansas Fest, PSA number 2. Which is actually happening over the next couple of weeks, both an in-person event and online. So if you're into old tech and not just Apple, so any of the old tech, whether it's Atari, boo, Commodore, Tandy, what have you, check it out. There's archive sessions from all the previous years, all kinds of photos and downloads on the website. Many of them are embarrassing videos of me doing this in a similar environment, but much more awkwardly. So there's a bonus there, Easter eggs. One of the things I really like about the retro computing community, and that is a community, it's very welcoming, much like the Mac admins has always been, at least for me as a cishet white male. Other experiences may not have been quite so smooth over the years, but hopefully the Mac admins community is welcoming to everyone. And if you are not, then see me after. Of course, I would never willingly join a community whose standards are as low enough to allow me to join. But like Mac admins with a Slack, everybody's individual blogs, podcasts, and all the other associated media, you'll find a zillion other people online that are into the same hobby as you, regardless of the hobby. And you don't even have to look that hard anymore. Kansas Fest used to be very obscure, but it's the internet. Apple II, retro, computer, nerds. It's like the second hit. Even if your hobby is only 100 people in the world that are still doing it, there's probably a Discord or a web server somewhere that's specifically the equivalent of the Mac admin Slack. And they probably all get together from time to time and socialize or have a conference. And they share their tips and show off their latest creations. So who knew that you could learn public speaking, such as it is, community management, or even just basic social skills, such as they are, from a 40-year-old computer, or cross-stitch, or cabinet making, or model railroading, whatever your hobby happens to be. The old saying goes, find a job doing something you love, and you'll never work a day in your life. I don't personally believe that you should try and make money with, make a living off of your hobbies, because when you do, then you'll need to start another hobby just to distract yourself and escape from that first one. But anyway, that thing you love, it doesn't have to be computers, vintage or otherwise. In fact, it better not be, because that's my thing. Well, what do you want to learn? What do you want to get better at? It could be engine tuning, right? Or wood joinery for cabinet making. But again, we're here at the Mac Admins Conference, so I'll keep it roughly career-oriented. Who in here plays D&D or tabletop games like they're going to be doing at the Charles Con? Yeah. So theoretical, hypothetical, ethical question. Who do you think has a better grasp of, say, managing people in a workplace, managing projects, someone who's always playing as a rogue, or a paladin that's always at the head of the party, or maybe the dungeon master? Making that transition from an individual contributor to management is tricky, and I know a lot of people that have done it and done it well because they had that desire and the right constitution, made the roll for initiative. Their existing hobbies may actually have informed their career path. How better to hone your people skills, of course, than by leading a group of adventurers to their untimely, grisly death, at least for pretend. What I'm saying is that thing that you love, your hobby, can be any hobby, really anything that you're passionate about. Making a connection to your career, to the skills that you use for your day-to-day job in some way, interpersonal skills, anything that requires you to talk to other people. Maybe it's working with large groups of people in, say, a tabletop environment, or community management in the managing the forums for your cross-stitch group and trying to keep those flame wars from catching on. So try and find a connection to your everyday job where you're dealing with people, dealing with projects, time management. It will definitely help you maintain some of the passion, the interest that you might have in your day job, especially when it starts to wane, and sometimes, some days. But when you're struggling, see if you can find or make some connection between the two sides of that work-life balance, and it'll make balancing the two a lot easier. It'll make you a better consultant or admin or manager or employee or a better cabinet maker or whatever in the process. And that is the actual point. So before I do some Q&A, it looks like I have plenty of time for that. So this is the feedback link if anybody wants to grab that QR code. Anybody, anybody? Nope, okay. So thank you. So it does look, it looks like I have some time, so another thing. We were talking at dinner the other night, some folks at my table, we were talking about how in a modern parlance, we are often making analogies and metaphors for the things that we did decades ago in our careers. So I come upon a new problem, a new user interface, or some kind of bug or conflict that I've never seen before. But it's like Darmok, Tanagra. It's just like that. I mean, what's the guy's name? His eye's uncovered. Anyhow. Shaka, thank you. When the walls fell, but that's disappointment. But it's Skara with his eyes uncovered. I don't remember. I just remember Darmok and Jalad at Tanagra. Anyhow, so a lot of times what I'm doing with modern problems is finding an analogy to an old problem that I've already solved, or something that I know they solved eons ago when they were trying to get, 2 transistors in a paper bag to get to the moon. So there's again, that depth of knowledge, those decades of people solving problems that are not exactly this problem, but they fit the shape of this problem. So a lot of what I do in relating my hobbies to my current career is with analogies, with metaphors. And one of the ones that I got years and years out of was spinning hard drives are a lot like a record player. So explaining to somebody that knows what a record player is, and that's getting harder and harder every day, but luckily so are finding spinning hard drives. But explaining, okay, so what happened to your data, it's kind of like you just ran the needle across the record. And it went, so now when you play the record, it skips. There's chunks of that record that are perfectly fine, and we can recover that data, and that might be fine, but there's parts of your hard drive that are never going to come back. Or it could be that something happened and the needle broke, and you're never going to be able to play that record until you change the needle. But all the stuff on the record is just fine. So we'll send it to Drive Savers and spend $800, get your data back, it'll be pristine. But unfortunately, I have to retire that metaphor now. I'm still trying to find something that I can use groundhogs for, because these are so, look at these guys. That's not an AI image, that's real groundhogs, that's cool. So cute. Anyhow. So with that, if I can get back to, did I lose my? Okay, no, where's Keynote? There you go. Now I can say, thank you. And if you have any questions or comments or derogatory statements, please go ahead and grab the box, the little shouty box thing. And in the meantime, you can enjoy. Is that working? There we go. So that should be all of the all the original Dancer iPod commercials in low-res text mode. Oh, I have that one too. But this is more Mac admins appropriate. But yeah, the Bad Apple one's on my YouTube, so you just got to look for it. So I've got, looks like 15 minutes. Questions? Oh, throw box or whatever, catch box.
I was just gonna make a comment.
Please.
You need to be on here.
It has to be recorded.
Oh, okay. If anybody's looking for a way when you haven't had enough computing during the day, and you're looking for a hobby where you can use computers, and as the speakers talked about, talking to people, either digitally talking to people or actually with your voice. I'm an amateur radio operator, and I find that the whole digital thing is taken off, and there's so many different modes, and it's like they started out with this.
Yeah.
When they started interfacing computers with radio, it opened a whole new world, and that's how come you have DMR radios. Probably most everybody who's used one at a school or doesn't even realize it's a digital radio, and there's a computer involved.
Yeah.
Not
It's a
only
little-
in the radio,
it's a
but
little- yeah.
not only in the radio, but on the other end of it.
Yeah, there's a big overlap in that Venn diagram of classic, retro computing enthusiasts and ham radio, amateur radio, in part because of software-defined radio, like you were saying, the digital radio now. There's a lot of, like I said, there's a lot of crosstalk between, getting this old machine to work, partly because, well, I want to get it to work so that I can get it onto my ham network or whatever,
Right.
and be able to transmit data to, I don't know, other people on the other side of the world that are also listening and want to, put it on a floppy disk.
I guess two things. One anecdote and one question. I had an experience that was a little bit opposite, where I went to an old computer to see the future, and that was in 1999 when I bought a Next station, and basically I wanted to see what what Mac OS was gonna be like when Apple turned Next Step into Mac OS 10. But that was the anecdote. Anyway, I'm just curious, did you start when you were younger on these computers and come back to them, or did you discover them as an adult?
A little bit of both, yeah. And if you squint really hard, that Next station does still look like a Mac. If you look at the command line anyway, it's or at least Objective C, probably not.
It was like suddenly being thrust 10 years into the future,
Yeah.
even though I was using a 10-year-old computer at
Yeah.
the time.
Oh
It
yeah.
was weird.
Yeah. Because it's suddenly you're using Unix. Yeah. But as far as my background, I had an Apple IIe when I was little. We had a modem, the first 300 baud modem, and I was dialing into BBSs and stuff. Eventually, that got replaced by a Windows machine because that's what my dad was using at work for, work. So the Apple II went, actually went to a friend. And then when I got to college and I was using Macs, there were still some of these around for like getting online, checking, online. Getting online, checking email. But most of the machines were like Quadras and Centruses before the PowerPCs at that point. And I was looking at these and going, these were, an SE was like gold when I was using one of those and first using the Windows machine. It was like, and now they're just like sitting in a bin. They were giving them away. And so, yeah, that's how I got started on the vintage machines. And then it's like, I used to use an Apple II. And so I got an Apple II and started learning and all that kind of stuff. But yeah, it was coming back to it as basically as an adult, in part because they were super cheap and literally there were schools and businesses just throwing them out. And so they were really easy to get. Not so much today, because people realize that there's gold in them, there are chips. But yeah, that was my history with it. Over here. Oh,
I'm amazed that I caught that. I've been told it sucks to get old, and I've been also told that capacitors definitely don't like getting old. So how much soldering have you done in your hobby here so far?
one of the things that I have learned as a part of learning, my way around old computers is how to solder. I did not too long ago. I had the reefa caps in a power supply blow up on me. That was the first time I'd had that happen because I'd heard about it a zillion times. Oh, you're going to let the legend magic smoke out, and so I did. But then, because at that point I'd already learned how to replace capacitors and desolder things, I've repaired the keyboard on this one more times than I can remember because I've broken the keys. Capacitors definitely go bad. There's a point in the 90s where like every capacitor that shipped has like a 90% failure rate. So between that and like CMOS batteries, that'll wreck your whole day when you open up a machine and realize that the acid has just etched its way into the PCB. So yeah, I've learned a lot of sort of double E 101 along with my CS 101. Is that the rain coming in?
Yeah.
All right.
There's a tornado warning.
Awesome. A warning or a watch? Thank you. Okay. We have the ingredients for the taco, but taco has not been spotted. So yeah, learning a lot about the physical, mechanical aspects of these, things like fixing a glitching floppy drive, things like that has been a big part of it. But that's less of an aspect of my Mac admin experience. I'm not having to rip out hard drives and resolder things very often.
Before we all die in this flood, apparently, I might as well make another terrible reference. How much do you care about the originality of the device and keeping it pure versus replacing every plank in that ship of Theseus? Which we're apparently going to have to get on in a few minutes because I think I just saw some guy with a bunch of animals in a boat near.
Noah, get the boat.
Yeah. So.
Yeah. So the stuff that I was showing you, which is not showing up on that screen, that's all being done in an emulator. So I'm really not all that concerned. Use as a mirror the display. There you go. So this is all. I mean, these are all things that I did almost entirely and almost exclusively in an emulator. So it may as well be the idea of the ship of Theseus as opposed to any kind of actual ship. But I do love the original hardware. But I am really hard on the stuff that I use. So anything that is in pristine, museum quality, hasn't been touched by the rays of the sun or whatever, I don't hold on to that very long. I find somebody that is a much better steward of that and give it away, sell it, trade it, whatever. Because I do stuff like, I built a battery pack for the 2C. I ripped out the guts of this 2E and put it in a brand new case. I use a bunch of these that are in bad shape, that are never gonna chime again. I use them as risers for my bookcase at home. So, and they're great if you put a little shim under the back so they're level, but they'll hold a surprising amount of weight. And I've got vinyl records and stuff. Anyhow, but to answer your question, it doesn't make any difference to me if that is an actual 1979 era, 6502, or if it's a modern drop-in replacement. As long as it works the same way, and with my eyes slowly failing, it doesn't even have to look like the old CRT anymore. As long as I can get, if I can get the bits into my eyeballs, if it's an emulator, it's the experience for me. It's not necessarily the atoms and molecules.
Good throw. So on that, the original Apple IIe did not have HDMI out. So could you talk a little bit about the things that you have in this one? That besides that, the other cards that you have in there, could you kind of explain what some of those are?
Oh yeah,
Because some people might not know there's a market for that.
Yeah, before the talk, I gave a couple people a tour of this guy. So and you can come up later on and have a look. So inside of this, and eventually this is going to bomb out because it's going to run through this loop more than 65,000 times or something. So inside of this is the 128K memory. So it's got a memory expansion, and then a super serial card. So it'll do serial communications to usually a USB to serial dongle that goes to a USB-A to USB-C that dumbs it way down but still talks to a Mac. And in between there, I've got a card called VidHD that is doing HDMI. And that's actually a little like a Raspberry Pi style computer on a board that's interfaced with the Apple II's interface, the bus. And yeah, and that board actually has USB and Bluetooth on it as well, but it's only using the HDMI only. Using the HDMI, the other parts of it are for like updating the firmware on it. And then over here, the last one with the blinky light is a CFFA. That's a compact flash for Apple card, and it has a compact flash interface and a USB interface. And all the stuff that's on that machine, and I can boot that up and show anybody later on that's interested, is running off of the little USB stick in 32 megabyte ProDOS image chunks.
So the reason why I asked about that is because over the pandemic, I bought a Timex Sinclair. That was one that, like, when I was a kid, I was like, Dad, this one's only $30. And he's like, that can't be a good computer for $30, even if it was the 80s. So I got one, and then I found this weird sort of aftermarket for parts. Hop-up parts is what my dad would have called them, like to make these things work again. So where did you find, where do you typically look for those kind of things? If there's somebody in here that's got an old microcomputer, maybe they're thinking about doing something like this.
A lot of the sellers, they just use eBay as their shop. Some of them do put their things on Etsy, or what's the other one? There's a bunch of hobbyist marketplaces, and then there are some places that are sort of clearinghouses for all kinds of things. But if you have a particular machine that you want to look for, did it crash? Woo! Yeah, it finally ran out of stack. But I would find, like for Apple II, I'd go to the Kansas Fest website, because there's links there to all the resources, all the people that make the stuff and sell the stuff. They go to the show. They, they do they do all of their marketing and stuff to that community because they know that's their market. For other things, I would look for Vintage Computer Foundation, VCF. They have forums for pretty much any of the different platforms and different communities that. Yeah, swap. If there's a swap meet or a flea market or.
VCF does.
Oh, yeah. But just specifically online, VCF has they have their online swap meet as well. But if you're like, okay, I need to find something for a VIC-20, go to the VIC-20 forum and see who's got stuff or where they recommend things. And that is all the time I have. Thank you for coming. Please like and subscribe. There you go.